My name is Demetri Dimatos. I'm the lead engineer for the Ansible core offering on Z. In today's presentation, we're going to discuss how we took our offering to the open source community on Z. We're going to discuss some of our processes and some of our tooling choices. And we hope that from this presentation, that'll help you when you take your offering to the community. A little bit about our offering. We're an Ansible collection. We consist of modules, plugins, roles, and playbooks. We enable Z to be automated with Ansible. We released the Galaxy and Automation Hub. Galaxy being the open source unsupported version, while Hub comes with service and support. We started about 6 months ago, and you can see already we have 3,400 downloads. We began by prototyping our code in GitHub Enterprise. GitHub Enterprise runs on IBM hardware. It's a relatively safe place to put your code. It provides us the necessary sandboxes to prototype and transform our offering. It basically gave us time to work while we planned our overall vision. As we started discussing our vision, we knew we wanted to be open source. We knew we wanted community engagement. We wanted individual contributions as well as partner participation. We wanted continuous integration and continuous delivery. We wanted quality documentation. And ultimately, we really wanted a first-class experience for Ansible on Z. After defining our vision, we were getting ready to shift to GitHub. We started thinking about how we would manage updates and releases. What workflow would we use? There's a number of workflows out there. There's GitFlow, GitHub Flow, OneFlow, Azure Flow, and many more I didn't even list out here. We ultimately chose GitFlow, primarily because I'm familiar with it. And even though I've worked in other communities, I've actually never started my own community. And this is why I'm sharing some of this information. It may not be obvious if you come into a community that's already set up, but when you're building one from scratch, there's a lot to think about. And this is one of those things you should be thinking about. With the various types of workflows out there, some have long-lived branches, others have tags, some have one branch, others have long-lived branches. There's just different versions and different ways of working. You should think about how you want your team to work. As we began thinking about our team, we thought there might be some skills around GitHub that were not necessarily apparent. So we started identifying use cases around using GitHub. Some of the use cases we came up with were develop a new feature, develop multiple features in parallel, create and deploy a release, bug fixing, production hotfixes, backing features out, and there's several more actually. After we identified the use cases, we went back through, drew little diagrams, how the flows look, and supplied each use case with commands. Now our team had a consistent way of interacting with GitHub. We also provided naming conventions for the branches, as well as the modules and variable names. Continuous integration and continuous delivery. We knew we wanted automation. We ultimately picked Jenkins, primarily because it met our needs and had a vast library of plugins. And for portability, we put it in a Docker image. Our pipeline executes whenever there's a pull request. That pull request is triggered by GitHub webhook. What that means is when someone pushes code and a pull request happens, that webhook triggers our pipeline. Our pipeline consists of about 50 different sanity tests, linters, PEP8, YAML-lint, etc., and security scans such as Bandit. We wanted a quality delivery, so we built out many different tests. Our pipeline also puts the binaries in Artifactory. It also stashes our logs for audit purposes. And I want to pause for a second. I highly recommend you keep your logs around. You never know when you might need to be audited. Finally, our tests run on ZVMs behind the IBM's firewall. Basically what that means, it runs on a mainframe. Now you might wonder, how is that community driven? Well, for now, we are looking at other options to provide compute to users outside the IBM firewalls, but in order to provide development time and compute time to those developers who are not part of the IBM network, what we did was we leveraged a webhook delivery service. So when a pull request happens, the pipeline executes. Those results from the pipeline are pushed back into the pull request through a webhook delivery service. This allows the user who pushed the pull to see the results and correct them and open another pull request if necessary. The delivery service we use is SME.io, and you can kind of see on the bottom there our different tests that we run during our pipeline. Documentation. We originally started with Markdown. We found that a little bit difficult to maintain. We ended up shifting everything over to restructured text, RST. Primarily because RST has many different tools to help you generate HTML. We rely on Sphinx, Sphinx themes, Sphinx versions, Ansible doc extractor, and Jinja. Sphinx will take the RST and generate HTML, as you can kind of see there on the right. It then will also put it into a theme that is also there on the right. Sphinx versions will allow you to create versions of your documentation so they can be selected with a drop-down. That way users who want to see older versions of your doc can select it to the corresponding release they have. Ansible modules are already heavily documented, so we leverage that, and we extract that documentation into RST from the Ansible doc extractor tool. And all Jinja does is it provides additional formatting that we find necessary and provides additional clarity. I want to talk a little bit about licensing. This could be a topic on its own, but it is important you understand that there is licenses you have to take into account for. Understand what your organization wants in terms of a license. Understand what your vision is so you can appropriately pick a license. That being said, review the open source initiative licenses that are supported and accepted. Understand the differences between proprietary licenses, copyleft licenses, strong and weak, and permissive licenses. If you have legal counsel or access to legal counsel, I recommend you engage them and understand a little bit more, but there is plenty of resources out there to learn from. As well, you should understand what it means when you fork code, particularly licensed code, how that forked licensed code will impact your code. We ourselves do fork licensed code. We understand the impact and adjust for it. Understand what it means to include licensed binaries. If you ship a binary, check its license, see how it impacts your code. Understand what it means to extend compiled code versus interpret licensed code. And lastly, copyrights, which pretty much provide a mechanism for you to secure intellectual property. That kind of brings us to the end of this conversation. I hope you guys found this helpful. Feel free to reach out to me, and I look forward to hearing your questions.